My dear friends, in this video, today I would like to explain the parameters, the parameters which differentiate different types of grinding wheels and how to select a grinding wheel or a grinding tool. So different types of different parameters will specify a grinding tool or a grinding wheel. Those parameters are types of abrasive material, grain size, wheel grade, wheel structure, and bonding material. So we'll see one by one. So abrasive material, actually the cutting process taking place in a grinding wheel is only because of the abrasive material, which is the hard material with the sharp cutting edges. So this is one of the important ingredient in any grinding tool or grinding wheel. So its general properties of any abrasive materials are hardness, wear resistance, toughness, and friability. So some of the examples for this abrasive materials are aluminum oxide, which is most common abrasive material used for grinding steel and other ferrous and high strength alloys. Then another abrasive material is silicon carbide. It is harder than aluminum oxide but not as tough, and its application include for ductile materials like aluminum, brass, and stainless steel. Also, it can be used for brittle materials such as cast irons and certain ceramic materials, but it cannot be used effectively for grinding steel because of the strong chemical affinity with the steel. So silicon carbide is not commonly used for steel, for grinding steel. For grinding steel, aluminum oxide is better. Then CBN, which is hardest compared to this aluminum oxide and silicon carbide, this is harder than this material, CBN, silicon boron carbide, boron nitride, is produced under the trade name Borazon by the generic company, and CBN grinding wheels are used for hard materials such as hardened tool steels and aerospace alloys. Then the another hard material or as used for abrasive materials are diamond. Diamond abrasives occur naturally and are also made synthetically. Diamond wheels are generally used for grinding like hard abrasive materials like ceramics, glasses, and cemented carbides. Effective grit geometry due to material loading at tip. So grit geometry may undergo substantial change due to mechanical or chemical attrition, leading to rounding or flattening of the sharp cutting points. This happens when the work material has hard or abrasive constituent. So if the work material is very hard, then this happens. That is the geometry of the cutting edge or the tip of the this abrasive material may change. A chip material adhered to the tip of the grit because of some chemical affinity can also change the effective rake angle or the cutting edge. Silicon carbide and ferrous materials. Silicon carbide abrasives are harder than the friable aluminum oxide, but they are usually inferior for grinding most ferrous materials. This is due to the dissociation of silicon carbide to react with the iron or at elevated temperature. Therefore, silicon carbide is not normally used for steel materials. Another important parameter of the grinding wheel is the grain size of the abrasive particle. The first one is the type of abrasive particle, then the second one is the grain size. Grain size is expressed in terms of sieve number Sn, which corresponds to the number of openings per linear inch. The diameter of an abrasive grain is given by dg is equal to 0.6 divided by Sn or sieve number. The larger the sieve of the grains, more will be material removal, but surface finish will be less. So when the grain size increases, sieve number decreases. And when the grain size increases, the metal removal rate will be larger, but the surface finish will be less. So if the grain size is more means it is coarse, and if the grain size is small or less means it is fine. So the grinding wheel is fine. So this is normally represented by the sieve number. If the sieve number is less, for example 10 to 24, the grain size is coarse. That means the grain size of the abrasive particles in the grinding wheel is larger size. So this is normally used for roughing operations. For if you want to improve or increase the metal removal rate, you can use abrasive, coarse abrasives or grain size. And 30 to 60 is medium, 17 to 180 is fine structure, and 220 to 600 is very fine. It can be used for super finishing operations. Okay. Now grinding wheel structure. So there are two types of structures, open and dense. In the open, there are a lot of voids in the structure of the bond. That means you can see here white part are all are voids. There is no material. It is loosely packed. That is known as open. And in the case of dense structure, it is closely packed. There is no void in the structure of the grinding wheel. So that will be more stronger. In what conditions these structures be provided? Dense spacing and medium spacing, open spacing. So these are the three different structures normally used for grinding wheel. Another important parameter is the wheel grade. It indicates the strength of the binding material. Wheel grade is actually it is the strength of the binding material. So normally the grinding wheel is the ingredients of the grinding wheel is the abrasive particles and binding material. So this is binding material is actually it is bonding. It bonds the abrasive particles or abrasive grids. So if the binding material is not strong means it may easily break. So this will indicate the strength of the grinding wheel. When the work material is hard, the grains wear out easily and the sharpness of the cutting edge is quickly lost. This is known as wheel glazing. So if if you are grinding a hard material by using a grinding wheel, the cutting edges or the sharp tip of the abrasive grids will remove very easily, and the grinding wheel surface becomes very glazy. That means that is known as wheel glazing. So if it is completely glazed means we cannot use the same grinding wheel for again machining. So we have to again make hard surface or the sharp surface on the grinding wheel by dressing. To avoid this problem, a soft wheel should be used. So when we use a grinding wheel for machining hard material, it is better to use soft grades. The soft grade can be used for machining hard surfaces. So these are the different the representation of the different types of grades. A to H is normally used for soft wheels, so this can be used for hard materials. And J to P is medium wheel. Then Q to Z, the grade Q to Z is for hard wheel, and this is widely used for machining soft material. If you are using the soft wheel for if you are using soft wheel for machining hard surface, then because of the softness of the wheel, only the grinding wheel worn out, but it will not make any problem with the sharp cutting edge. So this is normally used for machining hard surfaces. And if we are machining hard surface with a hard wheel, the cutting edge will blend very easily, and we cannot use for long time or for machining continuously. Then another parameter of the grinding wheel is the bonding material. So type of bonding material. So different types of bonding materials are used for different grinding wheels. These are the characteristics. It must withstand the centrifugal forces and high temperature. Also, it must resist a shattering during shock loading of the wheel. Also, it must hold abrasive grains rigidly in the place for cutting to allow worn grains to be dislodged so that new sharp cutting grains will be exposed, so we can use the same wheel continuously for long time. So these are the important characteristics of the bonding materials. Some of the examples of the bonding materials are vitrified bond. Vitrified bond, it is represented by V. It is strong and rigid, commonly used. Then the resinoid, it is represented by letter B. It provides shock absorption and elasticity. This is also very strong. Then silicate S, it provides softness and grains dislodge quickly. Then another bonding material is the shellac. It is represented by the letter E. It is used for making thin but strong wheels, possessing some elasticity. Then rubber bond is represented by letter R. It's for making flexible wheels. Then metallic bond, it is represented by M for diamond wheels only. So for diamond wheels, metallic bonding is used as a bonding material. So bonding material is must. It is one of the important ingredient of the grinding wheel, and different types of bonding materials are available. Now we will see how to specify a grinding wheel, that is the representation of the grinding wheel. So this is one of the example of the representing the grinding wheel. So 30, it's a number. It is normally used by the manufacturers only for their own purpose. That is 30. It can be any number. Then another is a letter that will indicate which type of abrasive material is used. So A is actually it is for used for aluminum oxide. Aluminum oxide. If the abrasive material of the grinding wheel is aluminum oxide, then this letter is A. If it is silicon carbide, then this will be C. So based on the abrasive material, this will change. So that is the second digit. Then comes 46. So this is the grain size. This is the grain size. So if the grain size is in between 8 and 24, it is coarse. It is coarse. And if it is 30 to 60, if the grid size is 30 to 60, this is medium. So here it is 46. It is in between 30 and 60, so this is medium. The grid size is medium. So when the grid size increases, that means the structure becomes fine. That means the grid is very small if the grid size is larger. For example, if it is 200, This number is 200 means the fine grit size. So can be used for very good finishing operations for getting good surface finish. Then the fourth letter is H. It indicates the grade. It indicates the grade, that is the strength of the grinding wheel. So H, A to Z can be used. Any letter from A to Z can be, any alphabet from A to Z can be used for this grade. So A is the softest. So when it becomes to Z, when it goes to Z, the hardness increases. So if it is Z means the hardest material for grade. So grade is actually the hardness of the, or the strength of the grinding wheel. So here it is H, so it is medium. Then next digit is for structure. It is for structure. Its scale ranges from 1 to 15. 1 is very dense structure and 15 is very open structure. There are a lot of voids. So this letter is 6. So this number is 6, that is medium. The medium range structure. Okay. If it is 15, which is open structure, and if it is 1 or 1, 2, 3, etc., it is closely packed. That is very dense. Density is high. Then the next next digit is the bond type. It is the bond type. That means type of bonding material. Bond type means the type of bonding material. If this letter is B, then it is resinoid. The resinoid bond is used. BF, resinoid reinforced. And if it is E, shellac. If it is R, rubber. If it is V, vitrified. Like that, we can represent this the bonding material. Then the last digit is manufacturer's private marking for wheel. That is optional. So this is the complete representation or signature of the grinding wheel. It is the complete signature or the specification of the grinding wheel. So any grinding wheel, this you can see like this, it is specified. So the first number is the prefix and the second is the abrasive type, abrasive material. Then the second one is the grain size, third one is the grain size, and fourth one is the grade, and fifth one is the structure, and the sixth one is the bonding material or bonding type, and last one is the manufacturer's private marking. So these are all about the grinding wheel and its nomenclature and how to represent the grinding wheel. Now how to select a grinding wheel. The selection of the grinding wheel is based on the type of work material. The type of work material. So we'll see what type of work material is used for grinding. So the selection of the grinding wheel is based on the physical and chemical characteristics of the work material. Also, it depends on the grinding condition. Then the type of grinding, that is torque removal from finish grinding, whether you are requiring finished surface or whether you are going for a hard surface or rough machining is required. Based on this, we can select the grinding wheel. So the selection is based on the selection means we have to see which should be the abrasive material of the grinding wheel. So based on the type of the material, for example, the aluminum oxide is having variation properties, and aluminum oxide is normally used for low strength and it is Advantages in fine tool grinding operation and heat sensitive operations on hard and ferrous materials. So aluminum oxide is used for machining ferrous materials. And similarly, silicon carbide does not use for ferrous materials. Like that, based on the type of workpiece, we have to see what should be the abrasive material of abrasive grit material of the grinding wheel. Then similarly, the grit size. Actually, the grit size will is implied based on the surface finish required. If the grit size is larger, means the metal removal rate will be high, but the surface will not be smooth. It will be rough. But when based on your requirement, that means if you want to use this grinding wheel for finishing operations, final operations, it must be having a small grit size. So the sieve size will be sieve number will be larger. And another thing is the grade. Grade is actually the hardness or the strength of the material. So that is also based on the type of material you want to machine or grind. Bond, different types of bonds we have already explained. So certain bonding materials are preferred for certain materials, etc. So these are the important parameters or the important things which we have to see when we want to select a grinding wheel. Okay, thank you.